Unit 15, part 368. No, Unit 15, part 14. We're moving on to section 6 of Klenk, page 290. Constructing proofs for arguments containing truth functional compounds. What I was just saying at the end of 13 was an anticipation of these. Got to thwart your old habits from doing the pure ones. These are the mixed quantifier ones. Again, like I said, in the exam, you won't be told what kind of problem it is, so you have to attend to the form of your formulas to figure out what kind of problem it is and what kind of strategy you need to use. Okay, so this is example N, worked out 290, 291, the main example Klenk works out in this section, section 6. So when presented with, if you were presented with this problem in the exam, the first thing to do, attend to the form of the premises and conclusion, right? So grasp that what you have, first premise, right, is in quantifier form, right? The first thought you need to arrive at as a result is that while the first premise is in quantifier form, the second and the conclusion are not. They are rather conditionals, right? Again, for the form of the formula is either a quantifier statement or a conditional or a disjunction or a conjunction or a negation, right? It's one or the other. Listen to Unit 14 lectures, I'll stress that ad nauseum. Okay, so you've got to see that premise 2 is not in quantifier form. It fails to satisfy the second condition of being in quantifier form, that is, the scope of the initial quantifier does not go to the end of the formula, it goes to here, right? So this is a conjunction. Last step in the order of construction of that formula is you took everything is G and you took everything is H, those simple universal statements, and you made a conditional out of them, right? You made a conditional out of them. Right? Last step in the order of construction is the sentential operator conditional. Same thing here, except with F and H, okay? Let me read Klenk's words in this opening paragraph of section 6, page 290. In Unit 14, you practice symbolizing sentences that turned out to be truth functional compounds of quantifier expressions such as if for all x, fx, then for all x, gx. Same form as premise 2 in the conclusion. Proofs involving these sort of formulas require a little more ingenuity than those involving just quantifier expressions or their negations. Here, there is no uniform strategy, such as dropping quantifiers, getting an instance, and adding the quantifiers back on at the end. So that's her saying that you need to sort of get out of the habit you will have gotten in, the sort of habits or method of solving things summarized on 288, right, with that, right? What do? You possibly CQN or QN. If you need to, if you start with negations, do the top and the bottom first. I went through this in the last part. Then you do the instantiations, you do a bunch of truth functional reasoning, you use a generalization rule, CQN at the bottom if the conclusion is a negation, and that's it, right? That's the habit you'll be in, and you have to sort of resist doing that. If you be aware that you might have to do something else with the quantifier statements. If you have a premise like this, for example, and a conclusion like this, do something else, like manipulate the parts, right? She goes on to say, right, remember that the QN and CQN rules are just like the replacement rules, bottom half of your inside cover, the Unit 8 rules, in that they are rules which present you with logically equivalent formulas, so they can also be used on subproofs. So you can use QN, I think she does so in if not this problem, then the next problem, the next one she does O. Yeah, in O she does it towards the end. Step 13 of O on page 292 uses QN on a subformula. So what I'm saying is you have to be aware that you might have to do something else with the quantifier statements, which are here parts of truth functional statements, to make the moves you need to make to get home in a proof like this, right? Because where should your thought go? First thing you have to grasp, premise 2 is not in quantifier form. It is a conditional. What am I going to do with it? I cannot use UI on this. I'll read Klenk saying that in a second. I cannot use universal instantiation on this. You'd be tempted to. I mean, look at how easy it would be if you could universally instantiate from 2, and if you could universally generalize to this. And the same fact holds here, right? This is a conditional. It is not in quantifier form. Therefore, this is not in the form of the conclusion of universal generalization, which is what it would be, because this is universal quantifier, but it's not. Universal generalization concludes with a universal statement. That's not a universal statement. That is a conditional. You have to grasp that. But if you could UG to that, and if you could UI from this, look how easy it'd be. I get FA and FA hook GA hook HA, hypothetical syllogism to FA hook HA, and from that instance I could UG to this. But you can't, because it's not of the right form. 2 is not in the form of the premise of universal instantiation, because universal instantiation, the premise is a universal statement, which 2 is not. 4, it is a conditional, and similarly for what I said for the conclusion. It's not a universal statement, it's a conditional, not in the form of the conclusion of the rule of universal generalization. So, right, so for these ones, continuing with Klenk, there's no uniform strategy, just as dropping quantifiers, getting an instance, and adding the quantifiers back on in the end, right? You can't just rely on that summary strategy of 288, presented on 288. The reason for this is that with a premise such as if for all fx, then for all xgx, with a premise such as that, which is not a universal statement, we cannot use universal instantiation. You can use modus ponens, modus tollens, or other rules involving conditionals, but not UI. We might even use QN, since the equivalence rules are applicable to any part of a formula, but we may not use UI. Okay, so 2 things from that. What she just said was what I said, that the QN rules are like the U8 rules, okay? But the first thing, right, you can't use UI on this. You may use modus ponens or modus tollens, right? So that's the thought you have to have. Oh, okay, I'm taking note of my proof, taking stock. I have seen that my second premise is a conditional. What do we do with conditionals? How am I going to use it? Oh, I might be doing modus ponens or modus tollens. So what am I on the lookout for? I'm looking on the lookout to see if I can derive, maybe, depending on what I need, right? Look at that, see how I'm going to get it. I might be looking for the antecedent of that conditional, such that I can do a modus ponens, maybe. Or I'm looking for the negation of the consequent, right? So that I can do a modus tollens, right? And maybe, this happens for a number of them, and I think example O on the next page, maybe I'm going to get the negation of the consequent by a QN. In fact, the one that I made up for the previous part, for part 13, was of that form, right? I did a QN on the first premise to get the negation of the consequent of the conditional that was the second premise, did a modus tollens to the conclusion. All right, so we'll come back and start on this proof.